Hello friends, today our topic is prime number. So what is the prime number? A basic definition of prime number is that it has only two factors, one and itself. It means that a number should not be divisible by any other number, completely divisible by any other than one and himself. Like there are examples for prime number 2, 3, 5, 7, 11, 13, see 11. If we calculate 11, that is it a prime or not. So our example is 11 prime or not? So our definition is prime number only has two factors, one and itself. So our question, 11 is prime or not? So let's start with 2. 2 divided by 11 equal to 0? No, it's not. If 3, can we completely divide 11 by 3? No, false. 4, false. 5, no, you cannot divide by 5. 6, no. 7, no. 9, no. 10, false. 11, true. So only number between 1 and 11. Is there any number that can divide 11 completely? So no, it means 11 is a prime number. Only two factors. So in this video I am going to teach you an algorithm that through which you can easily find that a number is prime or not. No matter how large that number is, it will give you a very quick response to find that is it a prime or not. So our algorithm has simple steps. Let's suppose if value of n, the input value, is less than 1, then it cannot be prime. It's not a prime number. If n equal to 3 or 2 or 3, then it is a prime number, and 2 and 3 are the smallest prime numbers available. The 3 is if n is divided by 2 or 3, not prime. So if value of n is divided by 2 or 3, it's not prime. Then there is our main core concept that we apply, that we start with I, start our counter from 5 and count up to the square root of our number. Okay, so if from 5 up to the square root of number, if we find that is there any number dividing the n, then this is not a prime. If we can't find any number, then it is a prime. So this is my algorithm. And the next step is, in each step we are going to increase I by 6. So this is the solution. And this is now I wrote a pseudocode for this program. See, this is my function name, is prime. If n is less than 1, all negative numbers are not prime, return false. Even 0 is not prime, 1 is not prime. If n is less than 3, return true. It means 1 is not prime, negative number are not prime, only less than 3 the value are 2 and 3. If n by 2 equal to 3 or n by 3 equal to 0, this mod operator tells us that if it's completely divisible by 2 or 3, then it's not prime, return false. Then we start our counter I with 5, check up to the square root, we square root the value of I, and then inside the loop we check if n mod I equal to 0 or n mod I plus 2 equal to 0. So this will tell us that n is completely divisible by the I, or the n is completely divisible by I plus 2, then it's not prime. And then we will increment the I by 6. So please check this step, understand this step. It says it is completely divisible. Start with 5 is completely divisible by 5 or completely divisible by I plus 2. So for each iteration we will take the value of I 5 and then 7. For next operation we will increment 6, it will become 11 and 13. So this so on so. Okay, so this is the algorithm that will give you quick answer. So this is the example. If 29 is prime or not. 29 is not divisible by 2 or 3. So start with 5. 29 is not divisible by 5. So 6, when we square root of 6 is 36. So 36 is greater than 29. So we won't continue the loop and say 29 is a prime.